Welcome to myprojectbazaar.com.
Title of our product is Analysis and Design of an Ultrabroadband Stacked Power Amplifier in CMOS Technology. Abstract of our product is presents the analysis and design of a two-stage stacked power amplifier with very broadband gain frequency response and power performance in a small chip size. The broadband load impedance match is realized using modified stacked field effect transistors with a resistive feedback by analyzing the matching condition of the source input impedance of the stacked FET. In order to further improve the broadband gain frequency response, the effectiveness of a gain expansion from a stacked driver amplifier is demonstrated to compensate the gain compression of the last stage amplifier. A two-stage three-stacked power amplifier has been implemented in a 180 nm CMOS technology. This power amplifier achieves a saturation output within a 25 dpm itself. This CMOS power amplifier designs becomes more difficult due to the low breakdown voltage and low output impedance. They are limited by the maximum allowable voltage. Many large devices have been typically connected in parallel to increase the current swing for the high output power. This power amplifier occupied area is small when compared to the existing systems. Now we are going to discuss about the flow diagram of our product. Our product can be implemented by using the two different stages. Each stage contains a different 4 modules to implement. They are capacitive block, inductive block, resistive block and field effect transistor. The sinusoidal input is directly applied into the capacitive block. The ability of the capacitive system to store an electrical charges. In capacitive block, the ratio of the change in electrical charges in a system to the corresponding change in its electrical potential. This output pulse of the capacitive block is directly applied into the resistive block. In the resistive block, the voltage applied to the electrical current. In inductive blocks, the electromotive force to be generated by a change in current flowing. The output of the resistive block and inductive current flow is directly applied into the field effect transistor unit. The output of the resistive block and inductive block current flowing is directly applied into the field effect transistor unit. This field effect transistor unit will be produce the first stage output. The first stage output can be directly applied into the second stage input as well as a capacitive block. In second stage also contain a same 4 modules: capacitive block and resistive block and inductive block and then the stacked FET field effect transistor unit. This second stage running flow is same as a first stage. This second stage stacked field effect transistor unit will be produce the final output. Now we are going to discuss about the running procedure of our product. Our product can be implemented by LT-Spice simulation tool. Open the tool window to create a new schematic using file menu. File to create a new schematic. Our product can be implemented by using 3 different products. They are N-stack and 3-stack power amplifier and 2-stage 3-stack power amplifier. First we select N-stack schematic. After selecting the N-stack schematic to save and run this simulation. After running the program, you will get the probe symbol to measure the input and output waveforms. Starting, you can measure the input waveform is a sine wave, and this is our input signal. In order to obtain the final output of N-stack amplifier, you will pick the probe in output terminal. After click that output terminal, they will show the output signals. Green color waveform is an output signal and the blue color waveform is an output power. The output power values will be shown in right hand side. Now open the second module. Open simul to 3-stack power amplifier. Start simulate it, save and run. This is an output waveform and power of the 3-stack power amplifier. Blue color waveform is an output signal of a 3-stack power amplifier, and then green is an output power of a 3-stack power amplifier. Similarly, open and run it the third mod. Open 2-stage 3-stack power amplifier. 2-stage 3-stack power amplifier is a final module. Save and run the 2-stage 3-stack power amplifier modules. This is a final output waveform of our product. Blue color is an output waveform of our product, and then green color is an power of our product. Our product power will be itself the 24 dpm. Thank you for watching this video.